All right, welcome back everyone to this week's episode of Pulumi TV. My name is Luke Hoban, CTO at Pulumi, and today I'm going to be talking about building components with Pulumi for your infrastructure. So we've talked, in previous weeks we've talked a lot about how we can, program the cloud with Pulumi. So how we can use some of the core capabilities of programming languages to work with containers, serverless infrastructure, and Kubernetes. And this really helps us to take a higher level view of how we can build, put together applications built out of these building blocks. Now, because Pulumi takes the approach of using programming languages instead of just markup like YAML or JSON or something like that, we have the ability to use many of the tools and get many of the benefits that application developers get when they work with programming languages to build application code. And we're able to bring those to the infrastructure space as well. And there's many benefits that you get from this. So you get things like the ability to have type checking, for instance, the ability to have rich tools in an editor and IDE. And most importantly, though, is the ability to sort of create new kinds of abstractions. When you think about what programming languages are really best used for and where they bring the most impact, really a lot of it comes down to the ability to sort of create reusable abstractions. And so if you think about kind of the days before programming languages, when people were typing in assembly or something like that in their computers, and you'd be working at a very low level of abstraction, you had all the tools that you needed to program a computer. But what you were missing was the ability to easily create reusable functions, reusable components that could express some subset of logic and then let you reuse that in other contexts. And this sounds like a really simple thing, but it really leads to, once you have this ability to really simply and easily create reusable abstractions and components, it lets people build libraries and higher level abstracts, these kind of richer, more abstracted components on top of the raw building blocks. And so really what Pulumi is sort of at its core is doing is bringing all those tools to create those kinds of new abstractions to developers. And we see that being used for two purposes. One, to sort of build some of these standard libraries on top of the core underlying building blocks of the infrastructure providers from the cloud providers and Kubernetes. And second, to enable you inside kind of an organization to define your own kind of components that describe things that fit to your production environment and that express the sort of pattern that you want to use and stamp out throughout your organization. And so today I kind of want to go and do a little bit of a deep dive into how you build these reusable kind of components with Pulumi and what it's like to build those and use those and some of the benefits that you get from having access to these sorts of components. All right, so let me dive in, and I'm just going to go straight into code. Actually, before I go into code, I wanted to show one quick thing. If you've visited Pulumi.com recently, we actually yesterday pushed some updates, which to update some of the UI here. And one of the things we have is a new Create a Project button, so a lot of more status about what's going on. But we have this new Create a Project button, which is a really easy way to get started if you're new to Pulumi and want to jump in and want to start using it to work with AWS or with Azure or GCP or Kubernetes. Whatever it is you want to interact with, you can jump right in here, click one of these buttons, and create a new project. So I actually already did this, created a simple project, and so I'm just going to jump over into that project that I have open inside my editor right here. Okay, so let's do a quick kind of tour of some simple Pulumi building blocks, and then how we get from there into kind of building our own components using those building blocks. So I can start off just sort of doing the kind of normal thing I might do. So let's say I want to just create an S3 bucket. So I'm going to say new aws.s3.bucket. You see here the nice ability to sort of get IntelliSense and completion lists that I get from using a real language. But let me just call this my bucket. And we see this is a normal resource, so as well as me passing a name, I can also kind of pass in some arguments here. So for example, maybe I want to say I want to turn versioning on. I'll say enabled true. So I can pass some arguments to my bucket, just like I might here as well. And this I can do for any of the resources exposed by Pulumi. So Pulumi has access to sort of every one of the resources that are available in AWS and Azure and GCP and a variety of other cloud platforms and in Kubernetes. And I can access them all using these sorts of constructors like aws.s3.bucket. And if I go to definition on one of these, we'll actually see, if I scroll kind of all the way back up, that this is a class bucket which extends pulumi.custom resource. So one of the kinds of resources that we have in Pulumi are these custom resources, which are resources defined by an implementation out in some other provider somewhere. So in this case, in AWS. But there's another kind of resource that I have as well that you'll probably often see if you're working with Pulumi, and that's a component. And so components are ways to sort of create what looks like the same kind of resource, but as sort of a virtual resource that is actually made up of lots of other pieces. And so, for example, with AWS, there's a concept of a VPC, but a VPC is actually made up of many more granular building blocks. And so when I want to actually stand up a full VPC that has all the subnets and configuration that I want, I actually need to stand up a dozen or so different AWS resources. And so I might want to do that instead by just creating a component. And so in this case, I'll call it my network. And I can similarly pass some options to this. So I'll say number of availability zones 2 and use private subnets. I'll just say true. Okay, so this is similar. It looks the same as AWS S3 bucket. It's just AWS infra.network. But in this case, this is actually going to be a component resource. So instead of a custom resource, this is a component resource. And we'll get into the difference that that makes in just a second. But the key is that to the user, these things they can use almost entirely the same. But this AWS Infra Network is actually made up of a few building blocks. So let me come in here and I'll just do a simple Pulumi preview to see what this looks like. I'll just scroll up a second. Okay, so we see when I preview this, a couple of things. So one, that AWS S3 bucket we see there, just like I'd expect as a normal resource that I'm going to create. But this network has this interesting ability to actually be a new node by itself. So this AWS Infra Network is a node in my tree. And then all of the things that are part of it are nested inside there. And so this gives me an easy way to understand that these are all related to this network. They aren't just a bunch of resources that I'm going to use. They're all implementation details of the AWS Infra Network. And that means I don't have to always worry about all these. I can trust that the person who designed this network implemented it correctly, that they implemented it to satisfy the sort of contract that was provided here, and that I can then go and use this like I would any other resource and let that component author take care of the implementation details. And I can take this further and do things like cluster equals new eks.cluster. I'll just create a my cluster. And this EKS cluster is actually a library that we built, Pulumi EKS, which makes it really easy to stand up an EKS cluster, an elastic Kubernetes cluster inside AWS. And so this thing has a bunch of parameters on it, so I can say sort of VPC ID is my network.vpc ID, and my subnets are my network subnet IDs. And now I could come down here and again do a Pulumi preview, and this time we'll actually see a lot more stuff. Because this EKS cluster actually turns out to stand up an EKS cluster in AWS requires a lot of different resources. And so here we see the EKS cluster has inside it other components, so the service role components, which themselves have some children. It has a Kubernetes YAML config group, which is a package of Kubernetes YAML configuration to deploy a dashboard, the Kubernetes dashboard. And then a variety of other resources that it needs to correctly stand this up, both AWS resources and Kubernetes resources. And so this gives you a sense that these components can actually be nested. So like the service role is nested within the cluster, and they can be fairly complex components which have very simple APIs. And that's really the key benefit that users get from these is they don't have to think about all those details. They can think about this API in terms of this higher level notion of just these handful of properties that are available to configure this component. Okay, so that's a sense of kind of what we can do with some of these sorts of components inside Pulumi. But let's go back to something simpler and see what it looks like to actually create one of these components ourselves. And so I'm going to start by creating a really simple example here. And what I'll do is let's just keep it really simple, and we'll just pass, let's create a new bucket. And then as well as creating a bucket, I'm going to do a little bit of extra work here. I'm going to do a for loop over a folder on my local disk, and I'm going to create objects in this bucket in S3 for every one of those files. So I can say like let files equals, let me import star as fs from, I'm just going to import a couple of libraries that I want to use. And so I'll say fs.reader sync, and I'll grab the /files directory, and I'll say for let file of files, and inside here we'll create an object. Okay, so bucket object is just going to store an object inside a bucket, and so I'll call this bucket object file, and then I'll pass the bucket is going to be the bucket I created above, so we're going to put it in that bucket, and then the content will be fs.read file sync, path.join /files file, and then we'll just toString this. Okay, so there we go. Really simple program here that's going to create a bucket, and then for every file in my files folder, and I'll just open that up here. I have this files folder here with 2 files in it, index.html and data.txt. And so I'm going to, for every one of those files, I'll just create a bucket object. And so this lets me kind of keep a folder on my local disk that's part of my project in sync with a S3 bucket. Handy way to just make sure that I've got some files in S3 every time I run a deployment from this folder. And so let me come back here and do that Pulumi preview again. And we'll see what it looks like when I just run this as some straight up regular Pulumi code. So we see kind of as we expect, this is going to create an S3 bucket. It's going to create a bucket and 2 bucket objects, index.html and data.txt. Okay, so this is just some normal Pulumi program. But what I might want to do is sort of make this into a reusable thing. I might want to use this for a handful of different folders, or I may want to use it across several projects that I have. And so I can kind of walk through kind of how we can bring TypeScript and JavaScript and a programming language to bear on that kind of problem. So the first thing we can do is just create a function. So create S3 folder. And maybe I'll say folder string, and we'll have this guy return an AWS S3 bucket. Okay, so we're going to create a simple function here. And we'll just take that code we wrote before, put it in there. And then instead of files, we'll just pass folder. And then finally, we'll return that bucket. Okay, so now we can do create S3 folder, and we can pass /files here. Okay, so this is more or less the same code as before, but now we've just taken this and put it in a function. This means we can sort of do something simple like, describe an S3 bucket. Okay, so simple kind of thing. We can document this. We can sort of do what we would as with normal sort of code with this component. Now the key thing is here that we're creating these functions and sort of the ability to have reusable abstractions and APIs here like this function. But we're doing it to create infrastructure. And so if I run this again, we'll see sort of Pulumi preview. And we'll see that this now stamps out this sort of thing. Okay, and so I could use this sort of multiple times. I could do whatever I want to kind of reuse this and keep this as a function. But there's a couple of things that are sort of maybe not entirely ideal about this. So one is we don't get one of these nodes of resources at top level. And the other thing is that I don't sort of get a nice API to this. It's very ad hoc, and that can be beneficial. I can sort of write any kind of code I want with a function like this. But I don't get a nice consistent API that feels the same as it feels like to use other resources. And so what we can do to address that is actually to create our own component resource, to create our own component which Pulumi actually natively understands. And so let's take this function and actually move it over to be a true component. So what I can do is I can say I'm going to make this the S3 folder class. What I'm going to do is say it extends Pulumi.component resource. So Pulumi.component resource, you can go to definition and read kind of about what this thing does. But it's just a kind of resource. So as I mentioned earlier, there's really 2 kinds of resources, custom resources and component resources. When I have one of these, what I want to do is create its constructor. So what is it going to mean to create one of these things? And I'm going to need to pass a few pieces of information. So I'm going to need to know what name to give to this component. So that's going to be the name that appears in this column here. And then I'm going to need to know the args. And so I'm going to skip that for now, and we'll fill in detail what that should be in a second. And then lastly, I'm going to take some options. And this is the options that let me configure how the resource is going to be created. These are things that Pulumi kind of deeply understands. And I'll talk in more detail about these in a second. But you see we actually have an interface called Pulumi component resource options. And so you can take that as an optional last parameter. Now, we have to call the superclass constructor. And this requires most of the same stuff, but one key additional piece of information is the type. And so again, this is going to be what displays down here. And so in this case, we're going to call this just S3 folder. We'll pass the name, we'll pass the args, and we'll pass the ops. Okay, so there's the simplest possible component that we can create. Just creates a folder. And in fact, if we come down here now and say, we just do this, and now we do Pulumi preview, we should see that we'll actually get a folder resource in the graph. It just won't have any children yet. So we see we get this S3 folder, which is just a virtual resource for this component, but it doesn't yet have any children inside it. Okay, so let's go ahead and move that code we used before, and we'll put that inside here. I'll actually just get rid of this code for now. Okay, so we're going to take that same code and we're going to use it to construct the resources within here. But there's a couple of things. So one, this folder that we passed in before, what we might want to do now is actually just pass that as the arguments. And so I'll just create a simple interface here called S3 folder args, and it's going to have a folder as a string on top of it. So now we'll just type args.folder, args.folder. And here now we'll pass. Okay, so there we go. So now we've defined sort of a nice interface to our args. Now we've defined a nice interface to our API, and because we're using a typed language, for example, now if we mistype this, we get that same error reporting, all the same nice benefits we had before. If I pass 12 here, I get an error, that sort of thing. But now I can have room for expanding this to accept additional arguments and additional inputs here. And so I can take, not just the folder, but I could specify that I want to turn on versioning for the bucket or any other parameters I want to expose to users of this component. Okay, but other than that, this code was exactly the same. And so now I can run my Pulumi preview one more time. And we'll see this time that although we removed the other line and are now just using the S3 folder to create this, we do still see the bucket and bucket objects getting created. So they're now getting created by this component. But we don't see the sort of thing we expected, which is that the folder is not the parent of these resources. And so we don't have this sort of nesting and an ability to understand that these are associated with that S3 folder. And the reason for that is that to actually indicate that a resource that gets created is owned by a particular component, we need to pass one additional thing, which is we need to pass parent:dis. So what this says is that when this resource is created, its parent will be the resource, the component here that is being used to construct this. And we can actually set the parent to any other resource, and that will create this the bucket objects a child. Now if I come over here and do Pulumi preview, we should see that those actually are nested underneath. Okay, so now we've successfully got those resources nested underneath, and they have their parents set to this component. Okay, so that helps for the nesting, but we also may want to expose some of the details of this to our users. And so in this case, we know we're creating a couple of things, the bucket and all the objects. So let's make sure that we have a property on this, which is the bucket, and a property which is the objects. So we'll have an array of those, and we'll have a bucket. And so these are just going to be properties I can set, push. Okay. And just to make sure, I'm going to say this.objects equals an empty array. Okay, so now we actually can see that the component that we have as a programmer when we're writing our Pulumi code now actually gets access to that bucket and that object. Since that means we could come down here and say s3 folder.bucket, and we could do other things with this bucket, like we could put additional objects in here, or we could use it as the logging source or logging destination for some other bucket, whatever we want to do. We have access to the underlying building blocks. And this is really important because it means that I can now compose this with other parts of my infrastructure. My abstraction is not entirely a black box. I can actually see the individual pieces inside and use those as part of my application. Okay, so that was building a simple component using and exposing some of the resources. And so one of the nice things about this is I can now come in, and I won't go ahead and type all these, but I can now go ahead and document each of these properties on the resource. I can document the class itself and the component, and I can document each of these inputs. And so I have this sort of rich ability to use all the sort of techniques I might for structuring and documenting and typing and getting that rich typing for components and classes inside a programming language for application development. I can bring those into this realm of building components as well. Okay, so we built a very simple component there. Now, there's a couple of other things that are sort of really interesting. I mentioned this resource options, and there's a handful of properties that I can provide there. And so one of the reasons why components are really handy is they let me, as a component author, not have to think about all those details and just get them sort of for free. So, an author here can do something like say, I want to protect this resource. So if I say protect : true, what that means is I want to protect it from being deleted. So if a user comes up and tries to Pulumi destroy, that's going to fail unless they first do a deployment that removes the protect : true. This is a really nice way to ensure that you can't accidentally delete these resources via Pulumi. So if I come over here, now that I've set protect : true, and I'll say Pulumi preview, actually I think I'm going to have to do Pulumi preview -- diff. Let me just do -- diff. This will show me the details of what's actually going to be created. And so now we'll see these little lock icons next to each of these resources. And so not just that folder, that S3 folder component I created, but every single one of these resources that I created inside it is also marked as not being deletable. And so this is a nice thing. The component author didn't have to worry about that. They didn't have to actually pass the protect bit through or do anything or think about protection. That's something that Pulumi took care of because this component says it wants to be protected. Every one of the resources that are parented by it is going to also be protected. And so that's a nice benefit to using components, is you sort of get this ability to connect in with the rest of the Pulumi model for free. One other similar thing is the ability to sort of use providers. And so if I come over here and say, Pulumi config, we'll see that I have some configuration set up, and so I have my AWS region set as US West 2. But I may want to have another AWS region, and so we actually now support the ability to say, I want to create EU West. I want to create the EU West provider for AWS. So as well as me ambiently using the one that's connected to US West 2, maybe I want to use region EU West 1. Okay, so now this is another AWS provider I have access to, and I can use this as well in a similar way. Instead of me saying protect : true, I'm going to say providers. And I'll say instead of for the AWS provider, let me use other AWS. And so what this lets me do is say, I don't want to use the built-in AWS provider that's connected up to this default region, the Oregon region. I want to actually override that and use this other AWS region, but I want to use it for everything you need to create inside this S3 folder. And so again, I'm going to type Pulumi preview -- diff. And here we'll see all the details of what it's going to create. So we're going to create this new provider. So you see Pulumi provider AWS, and it's called EU West 1. But then every one of these other resources we'll see, without me having to change anything as the component author, every one of these says it's going to get created by that EU West 1 provider. And so all the same resources are going to get created, but they're going to get created passing parent : this. All of this gets picked up automatically for you. And we'll continue to add more of these kind of resource options. And all of the time that we create, we add these options and the ability to specify additional parameterization. Those things will flow really nicely through all the components that you have in your code. Okay, so I think that's a pretty good tour of building that component. So the last thing that I can do when I have something like this is, I can export this out of my index.ts so that now I have this as a library that people can use. And I'll just get rid of this. So now I've created a package that actually, and I'll export this one as well so that people can use my interface. If they're using, just like in this case, JavaScript, I can actually go and package that up and put it in existing package managers. And so just like all of the libraries that Pulumi provides itself are provided via NPM, so things like Pulumi and Pulumi AWS Infra, I could go and publish this package myself. So I could just go and type npm publish, and that will actually publish this out to NPM as a package that I can access on NPM, just using whatever I specify in my package JSON. So here I could say, this is Reusable component demo. And this will now be a package that anyone else can come up and use and incorporate into their own applications. And this has a bunch of benefits. Just the fact that we're getting to piggyback on top of an existing package manager means you get all the various features of these package managers. You get the existing public NPM repository, which is easy to go and use just from any desktop environment. It has lots of tooling built up around it. You have the ability to pin to specific versions. And so if I come over here and go to npmjs.org, and I come over to something like @pulumi/AWS infra, this is a package that we were just using and that we publish. And this we actually publish to as part of every build of this library. And so you see I can go back to any version that was ever published of this thing, and I can go and choose to use that version, and I can lock my application to that version. So you get very rich ability with these components and packaging to specify the exact version of the component, to specify loose semvers if you want to always pick up patch releases, or to even have tags like dev, which is going to always be attached to the very latest release, even if it hasn't yet been officially released. So the last official release was 0.15.1 about a month ago, but we're doing active work on this library still, and so if you want to use some of those new capabilities, you can do that using the dev tag. And so all of this is all this ability to control the package manager is things you get kind of for free with Pulumi, because we're sitting on top of things like NPM. If you're building things with Python or you're building things with Go, you can take advantage of the package managers and ecosystems built up around those as well to do a similar thing and publish out these kinds of packages. Okay, so that ability to use both components and then to package those up and make them available inside package managers like NPM really means you can create a sort of rich set of libraries and reusable components that you can use across your application. So both things that are going to be useful for you, like this S3 folder, and things which are going to be useful for lots of folks, like the EKS example that we saw. Now, one last thing I want to show, I've been focused here kind of really on kind of some of the low-level infrastructure pieces, these AWS S3 buckets. But it's important to recognize that everything we've talked about here applies to any of the different cloud platforms that are supported, as well as Kubernetes. And just to give you another example of one of these that I think is kind of interesting, we have this Kubernetes guestbook example. And so Kubernetes guestbook is sort of one of these very standard examples that you'll often see for Kubernetes. And this is a simple example of that application just ported over from the Kubernetes YAML. You see there's a lot of text in here to create this, but it's really just creating three components, a Redis master, Redis replicas, and Nginx front end to serve the website. And so these three components are very simple and very formulaic. And if you were to actually read through this code, you'd see a lot of it feels very boilerplate. I'm doing really the same kind of things for every one of these. I'm creating a service. I'm creating a deployment for every one of these things. I'm using the same labels to make sure I use them for the selectors, for the metadata, and then also for the metadata of the service that's going to attach to that deployment. And so a lot of boilerplate here, and whenever we see this kind of boilerplate and this kind of repetition, that's a place where we sort of think, in general, from a programming language standpoint, hey, can't I name that pattern something? Can't I create a reusable component that represents all of that? And now tell people to use that reusable component so that they get to work at a slightly higher level. And this is really what we did in this version called in the components folder. And this is all in our examples repository at Pulumi examples, so you can go and check this out yourself. Is we took that whole example, which was 100 or so lines. Let's see how long that actually was. 120 lines of code and sort of a lot of boilerplate, as we were saying. We just boiled it down to what it really is. It's really these three things: Redis master, Redis replica, and a front end. And each one of those is very similar. They're a Docker image and some ports that are going to be exposed. and then some optional things like how many replicas do we want, whether we want to allocate an IP address, etc. And so we did this by creating this new thing called service deployment. The address where it can be reached is inside the cluster. And then internally, it creates a new component, this KSJS service deployment, and creates three things. Creates a container image out of some of the parameters. It creates a deployment, and it creates a service. So just that boilerplate that we saw in the previous example, we've just moved into a reusable component. And now it has a nice simple API on it, this interface service deployment args, which just has a smaller set of parameterization that parameterizes that sort of templated pattern. And so this is a really handy way to sort of up-level the way we think about something like Kubernetes. So instead of thinking about each one of these primitives as the only thing we get to work with, once we understand those primitives, we can move up and say, hey, now we want to build things in terms of a service deployment or some other abstractions in the programming model on top. Just like when we build the C standard library, that's just a whole bunch of code written in assembly, but it's something that I can think about and use at a higher level to make me a lot more productive as an application developer. Okay, so components, really handy way to let people work at a higher level of abstraction as they're working with infrastructure, whether it's in cloud providers or in Kubernetes. Okay, so that was a quick demo of some of those features. As always, you can kind of get started with Pulumi at www.pulumi.com. Get started working with containers, serverless infrastructure, and Kubernetes. You can reach us on Slack and with any questions. We're lots of great conversations going on there most of the time. And you can always check out our blog for a bunch of interesting other topics. We just published a blog post earlier today on lambdas is lambdas, which is a really fun topic, really great blog post. Definitely encourage folks to check that out. All right, that's it for today. Join us again next week and have fun with Pulumi. Thanks a lot. Bye.